DataRobot allows you to deliver real-world generative AI solutions with confidence. Today's highlighted solution is Enriching Datasets for better model accuracy. This is widely applicable across many datasets and use cases. So what is it and how does it work? Sometimes the data you have just isn't sufficient to build a world-class predictive model. But you have specific ideas about what additional information you'd like to have. Large language models can help you enrich your data very, very quickly compared to other methods of augmentation. This diagram shows tabular data being compiled into custom prompts and then using those prompts to ask an LLM for more contextual information. That contextual information is added to the original dataset to create an augmented dataset. When the augmented dataset is used for a predictive AI model, the accuracy improves compared to the original dataset without augmentation. The demonstration that follows shows the process of augmenting training data in a DataRobot hosted notebook before modeling begins. We're inside a DataRobot hosted notebook, and this section of the notebook deals with adding additional rich details to the training data. Let me scroll down and show you what we'll be producing, and then we'll go over the code that created it. Here's our data frame, and we've added this enhanced details column. I'll mouse over some of the enhanced details. This is all text which is outputted from the large language model, which is enhancing the rich description of each piece of equipment and should be very helpful in predicting its price. So where did all of that text come from? We start by defining two functions. One of them is called compile details prompt. This is the one that will actually create the prompt from the tabular data in our dataset. And then we have generate pipeline. This will transmit the prompt to the API endpoint of a large language model and capture the response. In our case, we're using GPT Turbo 3.5, but you could substitute this with any LLM that's accessible by API. To use those two functions together, we define a third function called getDetails, which will apply to every row in the dataset. This cell shows the prompt that is compiled for row 15 in the dataset. It primes the large language model what its role should be, and it asks, what else do you know about this equipment? It also provides some instructions about how the LLM should respond. This is the response we receive and store as an additional cell in our dataset. In this use case, we'll be predicting the price of some used equipment, and so these types of rich details will hopefully be very helpful for predicting the price. Now we're back where we started. We define a new column called Enhanced Details. We iterate through all rows in the dataset. Then we add it to our data frame. And that's how I was able to show you this preview at the beginning. If you now register this dataset and create a DataRobot project from this dataset, you'll be able to use that enhanced details column as part of your model building. This is how data augmentation is able to improve your overall model accuracy. With a platform approach, you can confidently build valuable and safe generative AI applications at enterprise scale. At DataRobot, our open, extensible platform helps you build quickly and operate securely to bring your generative AI solutions to life. Learn more at datarobot.com/platform/generative-AI, where you can also request a personalized demonstration or sign up for a free trial.